So yesterday all we did was just simplify when we were multiplying and when we were dividing. So now we're going to go a little bit further and we're going to manipulate these numbers before we decide to simplify. So I'm going to do one, you're going to do one. You don't need to write any steps down. They're the same exact steps from yesterday. So pencils down and just pay attention. So 5. This is all saying 5 times this radical, right? And this is saying times 4 times this radical. Well, good thing. All right, so good thing that multiplication is commutative, correct? So I could say 5 times 4 times this 4th root. They both have 4th roots. What do we do when we have two things that have the same index? We just put them under the same square root. No need to write two different ones, right? Just put them under the same one. So let's put them under the same one. Let's break these numbers down as we do it. How could you break up 24? 6 times 4, perfect. And x cubed, can't really break that up anymore because I need x to be x to the 4th. And 54 is 9 and 6. And another x. I'm going to go ahead and take a picture of this so that you have this when you copy it down. I don't want to destroy what we made right here, and I'll just manipulate this one. Sound good? All right, so I shouldn't have done that yet. I want to break it down one more time. I have 5 times 4 times, that's a really, really bad line. Two times 3 times 2 times 2. I wouldn't break down that, right? Times 3 times 3 times 2 times 3 times x. You are more than welcome to try and do some of this in your head. I wouldn't do it on a test, however, right? You want to make sure that you aren't making any mistakes. All right, change my color. All right, so I've got 1, 2, 1, 2, 3, 4 2s. Don't I need 4 for it to come out? Yes. So I've got a 2 that came out. 1, 2, 3, 4 3s. And x cubed times x is x to the 4th, so an x comes out. There is nothing left in here. What is 5 times 4 times 2 times 3 times x? How'd you guys do it? I just heard 3 different ways. That's the beauty of it. I didn't hear the way I do it. I did 5 times 2 is 10. 4 times 2 is 12. 12 times 10 is 120. Okay, so here's the difference for those of you that love calculators. And there's nothing wrong with calculators, but the only thing that's wrong with calculators is that when you have big numbers, you don't know whether or not you're right. So originally you could have done, let's see, what is 24 times 54? 1296. So for those of you that know, if you put 1296 into a calculator and hit the 4th root and get 6 and know it's right, then you're okay. But when I put in 1296 and get 6, I think that could be right, but I'm not quite sure. Because you could have hit something wrong. You're now using 4th roots, right? Good. I'm glad. You've been practicing. I'm just saying, sometimes it's easier to look and see and know that you're right and understand that you're right. Okay, so 120x is our answer. Go ahead and write that down and then finish this one on your own. Okay, so here is my work. This is just my whole mental math right here. Why am I taking out squares that should be cubed? Because there is way too much talking going over there, girls. Because this is 5 squared and another 5, which is a cube. So I pulled it out. Why am I doing squares? Because I'm saying to myself in my head, 75 is 25 times 3. So 25 is 5 squared. I'm just breaking the numbers down however I want to. You don't have to do it that way, right? Did anybody, how did everybody break down 75? 5 times 5 times 3, which is the same thing I did, right? No, it won't always be that way. Yeah. You got 315A what? A cubed. You messed up somewhere. A cubed, I'm sorry, Boston, that wasn't very polite of me. A cubed comes out, and then you have an A squared and another A, which is an A cubed, and that comes out. I wish you could find out where you went wrong. Not sure. Yeah, it looks like Janelle's going to help you. Any more questions? You didn't have to do it exactly like me. And originally I did 7 times 5 is 35, 35 times 9, and then I just said, I know what 30 times 9 is, that's 270, and 9 times 5 is 45, so I added 45 and 270, but then I looked back and said, oh, I could have just done 35 times 10 and subtracted the 35. But like I said, that's just me doing it without a calculator. Okay, let's move on. So, this is the same thing as saying this. If I have 1/2 and I have 1/3, can I add them just like that?
No.
No. Not unless I manipulate, girls. Not unless I manipulated them somehow. Unless I got common denominators. Or if you like to say common bases. Well, these are bases, right? This is a basket of 8, a basket of 32, and a basket of 18. None of those baskets go together, so why would I add them? So I'm going to manipulate these numbers or simplify these radicals and then try and find the same basket, which is going to actually come out very nicely. So 8 is actually 2 squared times 2. 32 is actually 16 times 2, or 18 times 4, same thing, right? So 16 times 2 is 4 squared times 2. And 18 is 9 times 2, which is 3 squared times 2. Kick out my squares, what do you think that they all have in common? They're going to have 2's left over, right? So now I have 6 root 2 plus 20 root 2 minus 12 root 2. 20 minus 12 is 8. 8 plus 6 is 14. 14 root 2. Go ahead and write that down and then try this one. Questions so far? You like that one? Nice and simple? Do you guys remember this from 7th grade? Chatting. So this is 5 times 2 squared times 3 minus 2 times 3 squared times 3 9 times 3 is 27, plus 6 times, I would do 9 times 12, which is 3 squared times 2 squared times 3, correct? So 5 times 2, this is 10 root 3 minus 6 root 3 plus 36 root 3. 36 minus 6 is 30 plus 10 is 40. 40 root 3. Questions? No?
Yes.
I'm sorry? Hi, back to Bradley. Okay. So pencils down. I need you guys to pay attention. What does this look like to you? Looks like two binomials to me. Okay. You can use whatever you want. Radicals get kind of crazy and they get messy. So when I don't want mess, I organize. Now, you know that some teachers, if you go higher, are not going to let you use this, which is like saying, you know, don't organize your stuff. But it's just like saying, please don't multiply like this. I'd much rather you multiply like this. You know what I mean? It's the same. It doesn't matter to me that way. That's what I'm trying to say. It doesn't matter how you do it as long as you organize it and get the right answer. So this is 4 root 2 and 2 root 6, and I'm going to multiply that by root 5 and negative 3, which gives me 4 root 10, right? I'm just setting it up so I can use a multiplication chart. 4 times negative 3 is negative 12 root 2. 2 root 6 times root 5 is 2 root 30. And 2 root 6 times negative 3 is negative 6 root 6. Well, I can, and this is why I like the box, because it just puts lines there so I can look at them individually and not get lost. You know what I mean? Can you simplify root 10? Can you simplify root 2? Can you simplify root 30? And root 6? That's like a basket of oranges, apples, bananas, and pears. I can't do anything with any of them, right? So that's your answer right there. 4 root 10 minus 12 root 2. Does it matter what order you put fruit in? No. But the analogy works, right? All right, so go ahead and copy that one down and go ahead and try this one on your own. All right, so I went ahead and FOILed it. So 3 root 5 times 3 root 5 is 9 root 5 squared. And 3 root 5 times negative 4 is negative 12 root 5. And 4 times 3 root 5 is positive 12 root 5. And 4 times negative 4 is negative 16. Same thing as this one, only this one I set it up horizontally and diagonally like a multiplication chart. It's the same exact thing. This one I think is easier to see it. This one is just linear. This one's just set up as it's an area model is what it is. Okay, then 9 times, the 5 comes out, it becomes 9 times 5. Negative 12 root 5 and positive 12 root 5 cancel each other out. Minus 16, so 45 minus 16 equals 29. Or, as I heard Caro say, if you would have originally looked at it, check this out. That's going to be way too thick of a line. You could have said to yourself, hey, this is the difference of 2 squares. Watch how fast this goes. 3 root 5 goes in here. 4 goes in here. 3 root 5 squared is 9 times 5 minus 16. Right? Which is exactly what we're going to use right now. So go ahead. Does everybody have this copied down? I want to give you a chance to copy this down. Okay, so let's move on to this. The last two we're going to do. So just pay attention. So I've got radicals in the denominator. Remember what we used to do when we would have imaginary numbers in the denominator? We use conjugates, right? 5 plus the square root of 2, which is the difference of 2 squares. So you should have been trying to exercise that skill because it's going to help you right now. Now, if it still makes you nervous to use the difference of 2 squares, I would really suggest your life as an Algebra 2 student will be much easier if you just practice, practice, practice until you get it. But if that just really irritates you, you're going to have to either FOIL it or use a box method. It's the only way around it. This is not going to go away, right? We keep coming back to it, right? Okay, so I think to begin with, I'm going to do the numerator, and I'm going to use a box to do the numerator. I need to move all of this down just one row. Make some room for this. Okay, so I'll do this one in blue. So I have a 4 and a root 2 and a 5 and a root 2. So that's going to end up being 4 times 5 is 20. 4 root 2, 5 root 2. Isn't this easier to, I can do it so much faster than the arrows. No, it's just me. Root 2 times root 2 is just 2. So that would be, in the numerator, 20 and 2 make 22, and 4 root 2 and 5 root 2 make 9 root 2. There's my numerator done. So I did that method. For this one, I'm going to do it the difference of 2 squares, for those of you that are comfortable with it. The difference, you just have to write your little skeleton. The difference of 2 squares. The same thing, I mean, isn't this a 5 and this a 5 and that a root 2 and that a root 2? So what goes in here? 5 and root 2. 5 squared is 25 minus 2, which is 23. That's pretty simple, and that's your answer. Go ahead and copy that down and do this one for yourself, please. Okay, so before I finish this one, I'll show you what I did. This time I FOILed it. So 3 times 6 is 18. 3 times negative 5 is negative 3 root 5. I'll be honest with you, I'm chalking it out because sometimes I make mistakes on these when I FOIL them. Then negative 2 root 5 times 6 is negative 12 root 5, correct? And positive 2 root 5 squared, which is just 2 times 5. So in the numerator, I have 18 plus 10 is 28. And negative 3 root 5 and negative 12 root 5 is negative 15 root 5. Then in the denominator, I found the difference of 2 squares, which is 36 minus 5, which is 31. And that's your answer. Questions? It's just going to take practice. I could do a ton of them, but until you go home and do them yourself, you're going to have, you've got to just practice. Do it for yourself. Make it your own. Okay. Let's look ahead really quick, guys. I only have a few minutes, and I've got to do your stamp sheets first. I need everybody's attention, and I need it to quiet down. This is going to help you for tomorrow. What is v to the 1/2? Radical v, right? What is that one? The cubed root, right? What about that? Look at the denominator. The denominator is in charge. The denominator is your index, right? So my index is 5. It's an x, and I have 3 of them. Check this one out. It's the root, right, of x. What's my index? 2, and to what power? There's 3 of them, just like I could have written it like this. 1/2 times 1/2 times 1/2, right? Or root x times root x times root x. This is what we're doing tomorrow. Okay? We're going to go from this to this, and then go from this to that. We're just going to go back and forth, back and forth, back and forth. So I just want to give you a preview of that. Here is your closing thought. You guys did a great job.